The Italian astronomer Galileo once wrote that the great book of the universe stands continually open to our gaze. But it cannot be understood unless one first learns to comprehend the language in which it is written. Throughout the centuries, we have turned our eyes to the heavens in an effort to fathom their complexity, meaning, and design. It is a timeless quest for discovery, and today it is enhanced by the most sophisticated instruments ever devised. Amazing tools of astronomy that draw the deepest regions of space into clearer focus than at any time in history. Unfolding before our eyes, a vast frontier of seemingly infinite wonder and size. During the next few moments, we will continue our search to understand both the mysteries of the universe and our significance within it, as we venture to the most distant corners of creation. And as we pause along the way to marvel at the celestial masterpiece the Creator has fashioned in the night sky, we will stand in a light more radiant than cast by any galaxy or star. The light of God's eternal power and truth, reflected in the miracle of all that He has made.
In all of history, this has to be the greatest time ever to be an astronomer, because the pace of discovery just keeps accelerating. The answers to so many questions we could have only dreamed of knowing in the past now actually seem within our reach. It's a tremendous challenge, because once you leave the solar system and head out into the realm of deep space, the concepts of distance, time, and quantity take on meanings that are almost impossible to grasp, at least in the context of everyday experience. You see, within our Sun's family of planets, we can usually count and measure using increments that are somewhat familiar. Thousands, millions, perhaps billions. But when you consider the universe as a whole, it's so large that you have to begin thinking in trillions, and then from there move on to numerical values that are even more inconceivable. And even amongst astronomers, we throw around these huge numbers as if we really understand them. Oftentimes, I'm not convinced we really do. I have to sit back from time to time and reflect upon what are these millions and billions and trillions and much bigger numbers that we throw around so easily. Now, to work with numbers that large requires a special unit of measurement. So astronomers have devised the light year. Simply put, it's the distance that light travels in 365 days. Think of it this way. We know that a beam of light moves at 186,000 miles per second. So in the course of a year, it'll travel about 6 trillion miles. At that rate, you could make a complete trip around the Earth in the length of time it takes to snap your fingers. Traveling that rapidly, a trip to the moon would take 1.3 seconds. You could reach the sun in about 8 minutes. And the nearest star outside the solar system, Alpha Centauri, would require a journey of a little over 4 years. Now, once you've established in your mind what a light year is, and again, it's the distance that light travels in 365 days, then you begin to realize what 100 light years must mean, or 1,000 light years, or 100,000 light years. And you would lose that entirely if you talked about miles in every one of those cases. Now, despite the enormous distances involved, technology has opened a spectacular window to the universe. And as we continually venture out, sometimes millions of light years from the Earth, we not only see many of creation's greatest wonders, we also have the chance to come face to face with the full magnitude of God's power. And it's an awesome sight.
Though its dimensions are enormous, our solar system actually measures about 1/1000th of a single light year in diameter, and is in reality only a pinpoint on one arm of the Milky Way galaxy. A cosmic ocean of perhaps 200 billion stars. To better understand just how large our galaxy really is, imagine the orbital pathways of the planets compressed into an area the size of a coffee cup. Within the parameters of this dramatically reduced scale, the Milky Way would still engulf the entire North American continent. Our solar system is located here, on the outskirts of the galaxy, about 25,000 light-years from its center. If we were to view the Milky Way on its edge, it would appear much like this. Its flat disk, measuring about 100 million light-years across, surrounds its bulging central core, a brilliantly luminous region containing more than 100 billion stars. Branching from this radiant hub, majestic arms comprised of gas, dust, and stars rotate like a carousel at speeds that can exceed 9,000 miles a minute. These arms are among the most beautiful of God's creations, and the location of mysterious and wondrous phenomena we are only beginning to understand. Scattered throughout the Milky Way, magnificent regions called nebulae move among the stars. These islands of hydrogen gas and dust, many of them thousands of times larger than our entire solar system, are illuminated by starlight, creating the most vibrant colors in the universe. Some of these nebulae, including the breathtaking Eagle, may possibly be stellar nurseries, locations where new stars are born. While others, like the Crab Nebula, are the products of an event that, though rarely observed, has captivated astronomers for centuries. In July of 1054 AD, Chinese astronomers first viewed and recorded the appearance of a spectacular new celestial body. They called it a guest star, and for 23 days it blazed as the brightest object in the heavens, except for the sun. Though they didn't realize it at the time, those ancient observers were witnesses to the violent death of a star more than 6,500 light-years away. Now known as a supernova, the exploding star hurled gas, dust, and heavy elements in every direction while forming the ever-expanding nebula. Until 1968, an aura of mystery surrounded the cloud-like mass. Astronomers could not understand why, after 900 years, the remains of a dead star could continue to shine so brightly. Finally, the answer was uncovered at the National Radio Observatory in Green Bank, West Virginia. After aiming a powerful astronomical instrument at the center of the Crab Nebula, then tracking it as it moved through the heavens, radio frequencies, not visible to optical telescopes, were detected pulsing in a precise, consistent pattern. The source of these unusual transmissions would prove to be one of the most fascinating celestial bodies ever discovered. Following the explosion that had formed the nebula, remnants from the dead star compressed into a small, extremely dense object called a pulsar. Measuring less than 20 miles in diameter, the pulsar spun rapidly on its axis while generating an invisible shaft of ultraviolet energy that swept through space much like the beam from a lighthouse. These constant bursts of radiation have heated and illuminated the Crab Nebula for nearly 1,000 years. Shortly after its discovery, this sequence of photographs provided a direct view of the pulsar, flashing within the great cloud of gas and dust. Since 1968, radio telescopes have identified several hundred of these mysterious remnants of once massive stars throughout the Milky Way. The death of a star can produce another, even stranger phenomenon. When a star at least 5 times the size of the Sun finally burns out its fuel supply, it can collapse on itself, forming a black hole. The gravitational pull of this galactic whirlpool is so strong that everything around it, including light itself, is trapped inside. The shape of a star is distorted and stretched while being relentlessly consumed by the inescapable forces of a neighboring black hole. It has been speculated that the center of the Milky Way may contain a black hole with a mass and gravitational pull millions of times greater than our own Sun. Less than a century ago, it was commonly believed that the Milky Way was, in and of itself, the entire universe. Nothing was thought to exist beyond its boundaries. Then, in 1924, high above Los Angeles at the Mount Wilson Observatory, a discovery was made that would dramatically alter the world's perception of the cosmos. Utilizing the most powerful telescope of his day, the astronomer Edwin Hubble conclusively determined that distant hazy objects in space, long thought to be nebulae within the Milky Way, were in reality individual galaxies, many as large or larger than our own. For the first time in history, a correct conceptual view of the universe was in sight.